There is something they're not telling you about the high-res photographs from Mars. In fact, that something is they've attributed you not getting these photographs to be able to see them to NASA's shutdown. But what they didn't tell you was the high-res instruments of the Mars Reconnaissance Orbiter are operated by the University of Arizona, which should be exempt from the shutdown. So why aren't we getting them? Wow. And not only that, this is perhaps, possibly, the best chance to get the best image of Three Eye Atlas Comet or whatever that thing is that there may ever be. Are they available? Did it get the imagery? We don't know. So why don't we know? Why aren't we seeing it? It just so happens that, like I said, uh, University of Arizona is, of course, a Arizona state-funded institution, not subject to federal funding and federal government shutdowns. I myself have worked for decades in the past as a contractor for NASA, not NASA, but a contractor, which is a private company contractor, which was always funded outside of the federal funding because we'd get a contract, we'd be funded. So when NASA shut down, we still went in the offices, we still worked, we still had access to the computers, everything. So just the fact that NASA shut down should not, in and of itself, deprive us of this opportunity. And not only is it NASA, there is typically undergraduate students and people from other universities and organizations working on high res. Yes. So you would think that some graduate student or somebody would get in there and take the greatest opportunity ever so far in the history of mankind to get the best resolution image of one of the strangest objects we've seen come into our solar system. But oh no, it's crickets. Why is it crickets? Oh my gosh, guys, this is incredible. So let's just give you a little background. The resolution from the high res camera at the distance that it was from Three Eye Atlas object, let's just call it that, should have been 30 kilometers for 1 pixel at best. And I say at best, 30 kilometers for one single pixel. Now, that's the best that we can hope for. Now, it's thought that the actual nucleus of this thing might be a huge 5 kilometers large, but that's far shy of 30 kilometers. So all these reports, all this stuff and hysteria you see throughout YouTube about, oh, we've blown this up and we're seeing structure, we're seeing multiple craft. Ooh, you can't get that kind of data. You're just getting digital garbage when you blow that kind of image up. And there's people say, well, we're looking at this from a Dobsonian telescope and we sit and resolve. They're not going to get the resolution that the Keck Observatory got even, or several of the cameras we're going. The best chance, next chance we're going to get is of the 19th of December when it makes its closest approach to Earth. So, and the best resolutions we'll get is from either the James Webb telescope or the Hubble telescope. Now, it just so happens so far the best image is from not the James Webb, but the Hubble telescope. So let's kind of bore into this. We'll talk about the data, and then we're going to come back to this thing with the University of Arizona, and we're going to talk about, we're going to shoot down some of the stuff, blah, blah, that's being said, and we'll look at some of the imagery that people are making, a whole lot out of, like ESA's ExoMars Trace Gas Observer, which is called the CASIS. Now, you got to remember it's European, so the acronym don't match the name in English, but it's observation. A lot of people have seen that. So we'll actually show that. But, and we're going to talk about, and ask a big question. Is this thing possibly one of the dark fortress objects that I talked about previously? But let's stay on this tear for a minute. Let's stay on this photographic resolution, why the high res camera on the Mars Reconnaissance Orbiter may be the best image we could get. And I say maybe because honestly, the limitations on the Mars Reconnaissance orbiter. Maybe the reason we don't have a report is it's really optimized for looking on the surface of Mars, not turning around and pointing out and tracking something moving fast in space, a lot faster. Now, of course, Mars reconnaissance orbiter moves pretty fast around Mars, but tracking an object, a faint comment against the star field, would be a lot more difficult. Although the Perseverance rover got it. Real smudgy photograph, which they had to put together a bunch of frames and look like a big long smear or bar in it. So it's possible that they really couldn't get an image. Maybe somebody was there trying and it just wasn't worthwhile, but you still have some kind of data in it. Now, in July 23, there was an instrument problem on the high-res camera, and so it's not really able to get to color photography. And that also means it won't get quite the spectral information you would be looking for from that one pixel. Now, bear in mind, the light on a pixel, when a pixel gets illuminated, it's either on or off. Now, how much it's on, I don't know what color it sees. There's some of these things in the newer CCD charge coupled devices and electronics, so you can get spectral information, but it's pretty limited when it's one pixel. So especially you're not going to get surface details, okay? That's what you're not going to get. You might get the polarization of the light. You might get color, intensity, mainly intensity. If you watch it over time, you might be able to see variability. So there's a lot of stuff you're not going to get. We're not going to be able to resolve the nucleus of this comet with anything we got looking at it. That's the scary part. So, like I said, this might have been the best chance. A lot of people are asking, okay, supposing there's a video of out there where what is it, Michio Kaku is asking why any of these space agencies releasing this. I don't know if that's him or somebody else just copied and made an AI copy of him asking these questions, but he did ask some good questions. For example, why aren't the Chinese releasing it? Because the Chinese has got that Tianwen spacecraft around Mars, and it's probably got fairly good resolution, maybe to a few kilometers, but it's crickets from China. Now, China would love to be able to one up NASA if they had a chance. They would definitely go for it. But then again, their instrument is not optimized for looking at space either. So it's obviously they probably did either what they saw made them soil their britches and they're keeping mouth shut over it, and they don't seem to be in a state of panic. So the most likely probability is they didn't get a worthy image. Not even a smudge like the the Perseverance or rover got on Mars. So other instruments, like I said, the Hubble Space Telescope, best image so far is about 71 kilometers resolution per pixel. That's the best we got so far. We got the Keck pictures. We've got, again, the ESA's EXO Mars Trace Gas Observatory, CASSIS, gases. Yes, funny acronym, right? But then again, you got to remember, the Europeans aren't exactly all speaking English. So, well, most of them do, but this acronym is obviously different. But its resolution, and I'll show you an image from it in a little bit. It did get a picture, but its resolution is only 340 kilometers per pixel. Now, you're not going to get a lot of geometric nucleus properties out of that. Although a lot of YouTubers are really claiming this. Anyway, but like I said, high res could possibly theoretically get 30 kilometers per pixel if they could aim it and capture it and track it. And like I said, they do have an instrument problem with the color resolution. And that's been in case since the 23rd of July. So the James Webb Telescope on the 19th of December or somewhere thereabouts should be able to get about 40 kilometers per pixel, which is really close. And it would definitely be able to track it. And probably that's our best chance for the best resolution photograph. The next best would be Hubble at 52 kilometers per pixel. Nobody sitting underground with a Dobsonian telescope, which are pretty good telescopes. It's ones you hang around the mirrors. A lot of the ones you buy are like 8 inches in diameter, 8-inch diameter mirrors. Some of these guys are a couple feet that people have made on their own. Now it's hard to make them bigger and get that surface, that mirror polished out just perfect, so you don't have spherical, all kind of anomalies in your image. with optics. But the Dobsonic telescopes are pretty good. They're made, you use like the cubes for forming concrete to make the telescope cube, stuff like that. So they can be built cheap and get high resolution images. The tracking with them is not always so easy because they're usually made on homemade bearings you move around. But if we're getting a comet from Earth, that's not a bad way to go, but you're not going to get anything better than Hubble, Keck, or James Webb Telescope by a long shot. So don't go telling me that you've seen all these details from photographs of these objects. Now, that said, we do know that ESA's uh, Janus Juice has got a camera that will be in deep space. It's on its way to the Jupiter icy moons. That's what the Juice name comes from, Jupiter Icy Moon Explorer, something like that. It's got its Janus camera, but its resolution when it's closest to Comet or whatever it is, 3I Atlas, is only going to be about 9,600 kilometers per pixel, somewhat less than spectacular. Anyway, Juno is at Jupiter, and eventually this thing will pass behind Jupiter. But it'll be passing by at a distance far enough away that even Juno's cameras will only have about 14,000 to 17,000 kilometers per pixel. Nothing to brag about. So again, we come back to high rise. That's really our best opportunity if it can track. And that's a big if. We just don't know that it was able to track it, and that may be why we're seeing nothing. But this whole idea that we're not seeing it because of the government shutdown, that's a little hard to swallow. Because you would maybe, typically there's an approval process and NASA's got to approve something to be released as part of the release protocol. But when you got grad students working on high res, when you got other universities, internationals probably, yeah, you would think some of those would just slip something out. Oh, look what I got. I mean, the temptation would be huge. I mean, you would be like famous if you could get an image of the best. If you could produce the best image ever produced and get it out to the public, you would be famous. So if you got one of these, if you're one of these guys and you want to become famous and you were in there and you got that data, hey, it's your chance. What are you waiting on? For some reason, it's crickets. So it kind of leads to the idea they really didn't get it. So our best shot is probably coming up when it makes its closest approach to Earth on 19 January from the James Webb Telescope at 40 kilometers per pixel. 40 kilometers. That means one pixel is illuminated. You're not going to get surface resolution at all. You might be able to tell some things about the coma, which is the gas cloud around it, maybe about the tail. You can see those things are a lot larger. But the nucleus itself is going to elude detection capabilities by these systems. All right, nobody else is telling you this, and nobody else is telling you what these resolutions are. Nobody else of the hundreds, thousands of YouTube channels and news organizations out there going blah 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 blah. Not a one of them have told you that high res has been operated by the University of Arizona. Not as far as I know. Or have they told you that grad students are involved, other universities are involved? Yeah. Okay, now we got all that. Another problem with JPL isn't so much a government shutdown. They're having a big layoff, big riff. They're cutting back severely over there. In fact, they're losing about 4,000 to 5,500 employees to get laid off. That's what I understand. So that's huge. So they got other problems to deal with, and that could be bigger. I mean, even NASA would be in there dealing with this if they weren't dealing with this big reorg going on. So that's always tough on an organization. When you lose that many people, that's cutting them to the bone. That's a huge, deep cut. Remember, JPL is a little bit different than the other NASA agencies. All the NASA centers, everybody thinks NASA is one big monolithic agency. No, all the centers have got their own personalities. They're all different. The one that's most different and a little bit outside the club even is JPL. JPL is got a lot of independence from the headquarters in many regards, in many ways. We'll go into that today. We may talk about that sometime in the future. But JPL's got a lot of independence. They're pretty much on their own. So, but the oddball thing is when you really rack up all the improbabilities coming out of 3I Atlas, when you think about the fact that it was 9 degrees off from the wow signal, that its mass is thought to be perhaps as high as 33 billion tons, that which is a huge number. When you look at the gases coming off of it, mostly initially carbon dioxide, CO2, about 87%, when it's 9% carbon monoxide, CO, and 4% water vapor, yet it's glowing green, and green glow is from C2, and we weren't detecting C2. That's weird. So the fact that we saw so much apparently pure nickel up front, that was weird. Of course, now, oh, we should see nickel and iron together. But suddenly, we have, it takes a lot to separate nickel from iron, but uh, suddenly they detected iron. And, suddenly, we go, why is it not CO2? Why no water? When this comet's this close to the sun, we're expecting to see water vapors. We're not seeing water vapors. Why is the tail and coma bigger than they are? Uh, well, there might be several reasons for that, but uh, one thing, it might not be a comet, it might be an asteroid. Some of the spectral data does say it matches some of the asteroids we've seen in the past. All right, all that aside, this thing is the oddball thing is suddenly we started seeing iron. Suddenly we started seeing water. And the thought that occurred to me was like, I saw in my mind these little aliens on board saying, "Oh, look, they're chattering at us. They're saying they're not seeing this. They're not seeing it. Let's turn on the water, dump some iron, so they won't know. We're not natural." Now, actually, Angry Astronaut Channel YouTube, he actually caught that, and I didn't think it was worth making a YouTube video over. He actually dove into that some detail and found a lot of other anomalies associated with that. So he made a good video on that a few days ago. So you might want to check his video out, Angry Astronaut. So I'll give him a kudo there. He did get into that. So, and he made it a very interesting video. So he wanted to know if they're actually watching us, signaling us. But what he didn't say, the spookier thing is, what he didn't say was, if they are monitoring us and discovering that we're expecting to see water and expecting to see iron and not seeing it, and they're responding by putting that stuff out, that means even more. That means if there's some intelligence there, not only is it monitoring us, but it's actually able to decipher our signals, what we're saying, monitor and saying, which means they got to know our digital formats. They got to know our language, the language of our computers, the ASCII codes we use, all the different signal protocols we use for our RF signals, how our internet works, APIs, all kind of stuff they would have to master. Now, that's a tall order in and of itself, and that's even spookier. How would they get all that? Do they already have somebody here that's learned all that and reporting it up? Or do they just have super good AI, quantum computing that can crack all these codes and figure this stuff out? And maybe they're going, oh, now we figured them out. Oh my gosh, this is what they're saying. Nah, I'm not saying that's the case. I'm not saying that's the case. I believe the chances are it's a natural object, but it might not be. There's still a possibility, because when you take that, like I said, the color it's green, the polarization, the approach where it's coming in with the 5 degrees of our plane, just the approach and the and the fact that it's coming in that far to the place from the wow signal, the probabilities are off the scale of when you factor all these together. That's the crazy part. I know I was figuring what probability one in 6.7 billion or something like that when I started racking up all these different improbabilities. The strangest one is a probability that could approach just about every inner planet of our solar system and be on opposite side of Earth when it makes its closest approach to the sun. Now that's kind of spooky in and of itself. Like, we don't want them to see us, what we're going to do. So the oddball thing about that is that if you were a technological civilization, and if you wanted to sneak in on a solar system, a fledgling civilization such as us, then you would use something like a comet to hide in. And indeed, you would want to make your closest approach to the sun on the other side of the sun away from that planet. That's exactly what you would want to do. Why? Because you can do burns there. Now, you've heard a lot about this Oberth maneuver lately, named after Hermann Oberth. He was one of the early German rocket physicists, even prior to von Braun. He did come to the United States and visit the von Braun team. I got a picture of him, at the headquarters there at the Missile Command in Huntsville, Alabama, back in the day, the 50s. Anyway, you can find that on the internet, by the way. He's also with Ernst Stuhlinger, who I used to know. Ernst Stuhlinger was a great guy. All that aside, uh, the situation is that if it's doing that, it could be. I just did out a video. You got to watch this video I put out called The Dark Fortress. It postulates why a civilization would not only want to go quiet, so you wouldn't hear or see them, they would actually probably want to move away from their star. And it just turns out that Oort clouds, Kuiper belts, have vast resources in them. As I showed in that video, you could actually produce, and if a star like our own, with the resources we've got, up to 1.78 trillion habitats that are a mile wide, rotate and produce artificial gravity called Bernal spheres, and coat them on the outside so they would look like a comet. Then this thing is probably bigger than that, by the way. You can make them that size or bigger. The O'Neill cylinders were envisioned back in the 70s with the current bridge building technology they had back then was designed to be 4 miles in diameter and 20 miles long. And you have like two of them counter rotating so you could point them without having to deal with the difficulty of moving angular momentum around. So there you go. Large structures could be built and disguised as comets. And comets are always coming through an inner solar system. So if you did have a desire to make a technical approach to civilization, you could do that. That's the scary part. If you wanted to do that, that could be done. The scarier part is that you would want to do it in such a way that they just wouldn't recognize you, and they wouldn't as a comet. Now, I'm kind of beating on the same horse here, but the Dark Fortress is how most civilizations may be living in comets and Oort clouds. It may be, and if you're coming from one of these, you don't have to be coming from a given star here, a given star there, because Oort clouds are so vast around each star system. They could be coming from anywhere in the sky, anywhere. So, and then the other thing is, if they're coming in at relativistic speeds before they approach our solar system, they'd want to slow down to like a cometary speed just to avoid risk of impacts with particles in our solar system, which would be totally catastrophic. Just any particle at relativistic speeds. So, while you're doing the slowdown maneuver, you could align your craft with the orbital plane of the planets, which this one is aligned. So that's kind of interesting. So it may be that 9-degree offset from the wow signal may be inconsequential. It could have been where this thing was before. Now, if it's traveling, it's a pure comet. No, it wasn't exactly there because that would be too far to displacement. But if it's a artificial object, it's possible. Or it could be a signal from another artificial object following it, giving it course correction data or something else, and we just intercepted it. Maybe. Oh, yeah. What I was about to get to, the scary thing is that if you were going to go into a civilization such as ours and surveil them, it might be because on the Dark Fortress premise or even the Dark Forest premise that you would want to possibly eradicate any threatening civilization, or just maybe surveil them, but you might want to eradicate them so that you don't have a threat from a very aggressive civilization springing out into space. You might want to nip it in the bud. Barney Frank used to, Barney Fife used to always say on Mayberry, nip it in the bud. So that might be the case. Maybe we're just at the threshold of being a threatening civilization. And if their technology is more comparable to ours, not, vastly more advanced, and you consider that our signals have gone out about, 80 light years, if a civilization were to have the capability with an Innsman drive or something like that to travel at about 90% of the speed of light and upon receiving our signal, they could be from a star system that's up to, 38, maybe up to 40 light years away. Once we turned on our radars and all that big heavy stuff back in World War II. And so maybe they're coming at us from, and there's like, 600 to 800 stars within that sphere. And, about 400 systems, because a lot of them are binary, and some of them are 3 stars in the system, like Alpha Centauri system. So when you look at all that, it's possible something could be coming here, especially if, according to the Drake equation, the Fermi paradox, you can, once you got spacefaring civilization, once we just a little bit ahead of where we're at now, like maybe 100 years, you can embark on colonizing the galaxy and do it in, span of 1 million years, which is very short in astronomical time spans, but very short considering a lot of sun-like stars with Earth-like planets are way, billion years, maybe 2 billion years older than our own sun. I mean, we should be hopping and crawling with these guys. That's the Fermi paradox. Why aren't we? So, there's a great filter theory, which might be the real answer. But if they, you think the sun would still escape the great filter, get out there and be out and about. And they should be here. And maybe they are. Maybe this came from our own Oort cloud, but probably not trajectory. But it's hard to rule out maybe the outer reaches of it. So a lot of questions here to ask. So, but if you're traveling a tenth the speed of light, then you're talking something between 7 to 8 light years out. Reasonable velocity with an Innsman drive. You're talking 7 to 8 light years out of planets, which reduces the set quite a bit. Star systems, but still there's a fair number within that range. And, it's about, 10 stars, including the Alpha Centauri system, which is 3 stars in one system. So, and there's a few planets among those, like we see a planet in the habitable zone of proximal B, the closest star to us. But then again, our Fortress says they don't want to be on those planets. They want to be in the Oort clouds, which, like I say, is even more frightening possibility. All that said, I'll show you some videos. I'm not saying that's the case, but it's really strange that this thing is making us orbit maneuver. Let's go back to that a minute. The orbit maneuver, if it's executed, it's scary news and good news at the same time. The scary news is if something suddenly does an orbit maneuver, then there's some intelligence behind it. The good news is if it does the orbit maneuver, it's trying to get away faster. That's what a lot of people aren't explaining this because they ain't rocket scientists like me. So orbit maneuver is when you get to the periapsis, or the closest approach to a body you're orbiting. In this case, going around the sun, we call it perihelion. Perigee if you're orbiting Earth. The closest approach. That's when your speed is the fastest because the gravity has brought you in, and you can save a lot of fuel if you accelerate at that point, and you can pick up velocity and go to a higher orbit. Like if we wanted to swing around Jupiter, we could get out to planets further out. Or if you wanted to swing around Mars or Venus is used a lot for this because Venus is actually pretty close to Earth more often than Mars is. Even Mercury Mercury is the closest planet to Earth because it orbits the close end of the sun on average. Not always, but on average. But a lot of maneuvers use Venus or Moon, even come back to Earth. There's also the slingshot maneuver, but this is similar to that in that you use your perihelion as a point to speed up. And so you're actually firing along your trajectory to speed up. The scary thing would be if you want to slow down and go into an orbit, this is also the time to do that. That's not the orbit maneuver. Nobody's talking about this. Then you fire, let's say, if you are traveling along like a rocket and you're going this way. Well, if you want to slow down, you turn it around where it's have thrusters in the front and you fire in the direction of your orbit. Then you will slow down and it will drop you into a lower orbit, or you could circularize a elliptic orbit. And then you could perhaps go into orbit of the sun. Now, for an object that's 33 billion tons in weight, It would take an enormous amount of force to do that. I mean, it's off the charts how much force it would take to do that. But what Avi Loeb points out is it could send out probes. Probes could execute these kind of maneuvers and land on Mars and on Venus. Well, they won't last long on the surface of Venus, they go in the atmosphere. Or they could go to Jupiter or Jupiter's moons. Maybe they'd be so small we wouldn't even be able to resolve them. And what I just said about resolution, if it's less than a few kilometers, you may not, well, you might see a bright light unless they got it painted dark or using stealth technology. But if it's, the size of, say, a space shuttle orbiter, you know, then you're not going to see it unless it's bright. Something, tootling along the size of a space shuttle orbiter off this thing, you're not going to see it. You're not going to know it's there. Then it could land on Mars, something even probably something as big as a starship just been designed to land on Mars. You wouldn't see that either. You're just not going to see it. It's going to land and disgorge machinery and maybe replicate itself and build a city or some capability. Maybe they could turn around and really come at us with something, attack us or whatever. I don't know. Or you could disgorge some missiles or something to shoot at the sun to make it go into a supernova. Oh, yeah. We also had a large CME that was directed at it. Maybe the sun's trying to take it out. So we don't want you here. Get out of my neighborhood. It's been hit by a couple CMEs. I'll show you that too in a little bit. All right. So this is all conjecture. The stuff about being a dark forest and a dark fortress, about it being a potential technological object, is conjecture. It's not based on fact, but it is based on it's possible. Avi Loeb says up to 40% artificial probability. It seems a little high, but when you look at all the improbabilities stacked on top of each other, they're crazy. When you look at how you would actually approach us if you were going to, it would be like three ILSs approaching us. That's the scary part. Same way, right? To come in perihelion, opposite of the planet you're mainly interested in. Then you could pull all kinds of stuff while we're not looking. Well, we really can't tell. And if they really wanted to surveil our civilization or eliminate our civilization, they'd want to do it before we had a self-sustainable spacefaring capability. I mean, the ability to get out in space and manufacture from the resources of space using in situ materials, which we're probably on the cusp of. You would want to hit us before we got there. So you could eliminate a threat. Now, that's all ifs, big ifs. So I'm not saying it's the case, but I'm just saying if. And if they were going to do this, and if you go back to Fermi paradox, they should be here already. They should be watching. So you need to watch that video. I'll show you the link to it a little bit. I'll just show you the video, and I'll put a link up here in a little bit. So let's look at some websites real fast, and we're going to call it a video here. I'm going to show you some things. All right, so here they're talking about the orbit maneuver in this article. And it says, hey, if this is a technological object, we're about to know about it because they'll be making this maneuver. So, yeah, whatever the case is. So this is a kind of an interesting thing. So, yeah, we'll have a chance on October 29th. What do we got looking at it that's really going to know? That's when it makes its closest approach to the sun. It's October the 29th. That is perihelion. Parapus. Now, this is the video from the CASIS experiment that the European Space Agency has. CASIS, that is again the ESA's ExoMars Trace Gas Orbiter. So if you look at this, it looks like you can see structure rotating. But know this, the nucleus, what you're looking at is the coma, the dust cloud around it, because the nucleus, and the resolution is terrible, because the nucleus is probably no more than 5 kilometers, and this thing is, the resolution, again, of this CASIS camera is 340 kilometers. So you're not going to know what's on the surface of this thing based on this. So what you're seeing is just digital garbage in terms of it looking like it's got structures on it and rotate. A lot of YouTubers went in and blow this up or claimed to blow it up and said, "Oh, look what we got here. We found and run through various filters." That's all hooey. I don't care what filters you run it through, what processing you're doing. You can't get that. You can't get surface details out of something where you've got a resolution of 1 pixel that's small, that's bigger than the size of the object you're looking at. You just cannot get that kind of detail scientifically. Now, this is one of the Webb Observatory's pictures of it where they got a lot of good spectrographical data out of it. And this is where it's at right now. Let's see if we can blow this up. This is where it's at right now. This will not hit the stop button. Hang on. The comet is right here. Earth is over here, and the sun's in the middle. So we can't see it. We're not going to see it until early December, maybe mid-December, because it's just going to be too much sun between us and it. The sun is huge. So we're trying to look through the sun to see this thing. We can't see it. It's past Mars. It's getting close to Venus. Venus is coming around, and then it'll be close to Jupiter. So we'll kind of clock this through a little bit and just look at it. And on the 29th, right here is that it's at its closest approach to the sun, which is not directly opposite of Earth anymore. It's still too far away for us to see it, and it's still on the other side of the sun from us. So it's just past, but a couple days ago, being an absolute opposite from Earth. So now look, it's coming really close to Venus here. So maybe you can, yeah, right there. It's really close to Venus. And then we'll walk it through a little bit more. It's going through the orbit of Mars. It's going away. So it don't ever approach Earth. This comet, or whatever you want to call it, is coming nowhere near Earth. I think the closest is going to be like 1.36 astronomical units away. And astronomical units, the distance between the Earth and the sun. It'll be that far from Earth, over 1 1/3 the distance between Earth and the sun away from Earth. So that's why we can't get a resolution. And now I'm just going to let it play on out and exit. See, it goes in behind Jupiter. Still some distance from Jupiter when it does that. So, all right, let's stop this thing. Let's make it smaller. And we'll look at some of those other articles on here. So, this is some of the spectrographic data. Now, according to Avi Loeb, he's going, we're seeing nickel tetracarbonyl. Nickel tetracarbonyl is a manufactured substance. I don't want you to get that's manufactured. But the paper that this was based on didn't say we saw nickel tetracarbonyl. What it said, and I think some of this is a misquote of Avi Loeb, quite frankly. I'm not going to sack Avi Loeb making that mistake because reporters always get things wrong. And they hear somebody, they hear what they want to hear and they write it down. I've never seen a reporter get, or any news article that's 100% correct on anything ever. But this is the paper that it came from, and this is talking about the carbonyls. And what it says is that one of the ways of making nickel is from the decomposition of nickel carbonyl, NiCO4. That's one of about 4 different ways of producing nickel. They didn't say they saw it. They didn't say it was there. This is something nobody else is telling you. I'm bringing you news and content that's technically correct that nobody else is bringing you. I'm saying a lot of these things people are claiming are conjecture or not true. Now, this dark fortress, that's conjecture, but it could be true. But this also could be true, but it's not a given that this is the case, okay? It's not a given. And I doubt Avi Loeb said it was a given. I think he was misquoted. That would be my guess on that. So Avi Loeb is pretty darn good. He may be believing, high chance of being alien content, but he's not going to go out and say something that's not based in science. I haven't seen it. Then you got these guys that post on X all day astronomy. They make all kind of claims. Like they're saying there was chromium Nickel and chromium known as nickel tetracarbonyl. There's no chromium in nickel tetracarbonyl. And if you go back to this article, there's nothing in the article about chromium. Nothing. Zero. Zilch. So when you get guys like this, it's going here and posting stuff like that. And I've seen several other posts on this thing that were putting out things that are totally unsubstantiated. So I don't trust, things you see posted on X a lot of times. Don't trust a lot of your YouTube content because, people are jumping to conclusions quite often. Now, this is the case where we know that the International Asteroid Warning Network was initiated, and a lot of people thought, "Oh my God, NASA's got defenses. NASA defenses have been turned down due to this comet." Well, that's an overstatement too. Basically, what this says is that they're trying to improve astrometry for comet observations. Basically, they want all the telescopes turned on and looking at this thing when it makes its closest approaches. They want to be able to look for it we could sit in late November. It's a possibility to really be looking for it between November 27th and January 27th of 2026. That's what that boils down to. So this has been overblown. NASA doesn't have any defense system to send out against this thing. Uh, we did a dart rendezvous impact one time with a comet, an asteroid. I did a video on that. Now here, this is the Soho event that occurred the 21st, just a couple of days ago. Huge CME. I should cover this on my Green Grids channel just as to underscore the threat to our power grid. This thing is giant. So it would have impacted this CME will be impacting probably today, Comet 3I Atlas. So some people think, well, maybe Comet 3I Atlas instigated this. That means it would have had to send something really huge to the sun to do that. And that's just a tall order. I don't think at all that's the case because the sun's been shooting these off. So, I was kind of joking earlier. Maybe the sun is going, man, we don't need these guys. Let's take them out. Because it could take out a technological civilization, unless, unlike here on Earth, any smart technological civilization approaching a star would have their systems hardened against EMPs, CMEs, coronal mass ejections. So that's just totally coincidental, I would say. But again, that's kind of interesting. So seriously, guys, this is my video on my Green Greg's channel that you'd want to watch. Not Green Greg's, Galactic Greg's, this channel. On this channel, come in on this channel and look for this video. It was the previous one I posted. What's really out there? I'm talking about the Dark Fortress concept. Now, I consider it a spooky concept, so I delivered this with a spooky overtone. Let me stop the share. I really read the whole thing. I made it poetic, a lot of poetry I wrote for this, and I gave it a real spooky overtone, a real spooky theme in the way I delivered the topic. And, I did that for effect because I thought it fit with the theory. Some people don't appreciate that, but hey, it'd be great for Halloween. So it's possible. I mean, if there's alien civilizations out there and they discover that, hey, we don't want to be detected, and we're around our star, wow, everybody's going to be looking here. They want to get out and get away and get out into the Oort clouds, the Kuiper belts, and hide in the comets. And the comets are a great place to develop a civilization. 1.78 trillion mile across Bernal sphere top space habitats, or a smaller number of much bigger ones, is within the realm of possibility. You can build worlds that are like, we're talking, 2 we're talking billions of times more surface area than Earth. You're talking a lot of surface area available. You could build entire worlds the size of the Earth and just make them nature preserves, put critters in them to run around and and let people live native inside if they wanted to. The possibilities are off the charts what you could do out in the comets and asteroid belts with a little technology, especially if you've got good energy technology. But for this Bernal sphere size of small modular nuclear reactor would be good enough. Good enough for producing your power, your light, your heat, and have some radiators to get rid of the waste heat so you don't melt the comet you're hiding in. And if you want to add a propulsion system, still a nuclear reactor, an Innsman drive, and off you go. Uh, that's something you need to look at. But for a space settlement concept, that's huge. That's huge. Um, some people are, I won't go into that, but some people are saying, you believe in God? Yes. God's a lot bigger than this little universe we live in. So there's nothing saying that our expansion is going to change anything in that realm. That's a whole nother topic. But so this is interesting. So I would say be on the watch out around early December, mid December. And let's see if this thing shows up on the other side of the sun when we expect it. If it's earlier and they're accelerated and then the hover maneuver, then like I said, you've learned two things. One, there's something suspiciously potentially intelligent with this, and it's trying to get away, which would be a smart move. Two, if we don't see it when we expect to see it, and she slowed down, watch out. Like Avi Loeb told everybody, take their vacation before the 29th of October. Well, I'm actually taking a little bit after that. So I'm not that concerned about it because I do believe it's a natural object, but I can't say that it is. And since I've come up with this new theory to answer the Fermi paradox, which really deserves an answer, and I think it's the best answer if anybody escapes the great filter. I think some civilizations would. The dark fortress would be the answer. And according to that, they ought to be everywhere. They should be out there. And they would want to surveil us. This is how they would do it. Exactly how they would do it. Yikes. But it's a comet. Yeah. Keep your eyes wide open, head on swivel. Watch this thing. Let's just see. What do you do if it's not a natural object? I wouldn't want to be in a city. Let's put it that way. Woo-wee. Would not want to be in a city. Get out of the cities. Many reasons for that. So to see my video on Dark Fortress, look up here. Either here or here. Look up here for the Dark Fortress. And I want to say thank you for watching. And uh, subscribe, bang the bell, and click all. Again, thank you for watching. Greg out.